Today we're going to be talking about AI data provenance. I'm Ayush.
I'm Danny.
Sweet. And so the idea is that there have been a lot of approaches suggested for this problem of how do you recognize AI generated content versus camera generated content versus other methods of generating content. For instance, this is particularly relevant because recently the AI executive order came out saying that we need a way to be able to authenticate and detect AI generated content. Unfortunately, a lot of the problem with authentic communication is that people manipulate the data in different ways. That means that existing solutions which attach signatures to images often will result in those signatures being removed or deleted as that image is widely disseminated on the internet.
And so to elaborate a little bit more on existing methods, like Ayush mentioned, every single approach right now attempts to actually embed a watermark into content. Certain approaches are more resilient to certain types of transformations. As you can see, the most particular ones are things like JPEG image compression, screenshots, and taking pictures with your phone. Again, all these methods suffer from one fundamental issue that if you embed content into an image, multiple transformations to that image will fundamentally remove the watermark.
Unfortunately, these watermarking methods, while they come out very often and claim to embed it inside the image, they're often quite poor. For instance, this Google one relies on, instead of cryptography, in which algorithms are public and anyone should be able to break it, actually, this algorithm relies on security through obscurity, where the algorithm is not public. Similarly, ones that are public actually have been entirely broken. In practice, the schemes don't really work. And so we need a retrieval system that doesn't rely on watermarking, but is robust to all of these transformations. So we can see that as we do different kinds of transformations, like Daniel mentioned, the perceptual similarity to the original content changes as you do more and more of them. For instance, if you compress again and again and again, it'll rapidly become dissimilar, but if you screenshot or resize, it might stay more similar as you change that transformation more and more. So what exactly is a perceptual hash? Like, how do we evaluate similarity to original image? You can imagine some intuitive algorithms are, for instance, the palette. And so even if, for instance, you crop this image or you blur this image, the palette will likely be very similar. Another algorithm is, for instance, downscaling the image to an 8x8 image and then taking it into 4-bit grayscale. And so this means that even if you slightly change the contrast or add artifacts, this downscaled image will likely be very similar, if not the same. Similarly, one can imagine you could extend this to neural algorithms. So a neural network can say this is a fox sitting on a tree. And these, of course, have adversarial attacks, just like any other algorithm. But the idea is that different algorithms are robust to different kinds of adversarial attacks. And if you combine a potpourri of algorithms that in fact can change and evolve over time as people break earlier and earlier algorithms, then you can build a robust system that over time is constantly updating itself to be more robust to these new adversarial attacks.
And if you want to play around with what exactly perceptual hashes are, you can just go on our website at morpheus.pix and drag in some images down here. This, for example, are the perceptual hashes of two similar images that were screenshotted. And as you can see, without really delving into it, the color hash and neural hashes, as well as the block hash, is relatively similar. Great. So why are we using perceptual hashes? Because as you mentioned, perceptual hashes are a great way to figure out whether images are similar or not on some semantic level. Perceptual hashes and different perceptual hashing algorithms are resilient to the transformations that we mentioned before, where original watermarks are not. For instance, the neural based perceptual hashing algorithm is very good at identifying similar images after screenshots as well as JPEG compression. And again, as you mentioned, the idea here is to use a potpourri of perceptual hashing algorithms to make sure that we can indeed identify when two images are similar.
One of the most important things to note in that slide was that different perceptual algorithms, hashing algorithms, fail on different images. And so actually by combining a bunch, it turns out we can have a pretty good reconstruction method, even just given an image without a watermark that's been transformed from the original one. And so, for instance, we can break down the actual structure of how Morpheus works into two phases. We can have the image generation phase, in which the content producing organizations, say it's Midjourney or OpenAI or even your camera, calculates the perceptual hash of all of these images. Subsequently, it can make them public without actually revealing the original image. And we can do this by adding another, say, SHA hash on top of it. And subsequently, we will combine this with the images actually being consumed later.
Great. So to walk through how the Morpheus system works in a little bit more detail, as you mentioned, the the high level, this can be broken down in two phases: the image creation phase and the image analysis phase. In the image creation phase, a content producing organization like Midjourney will produce an image like so, at which point we will compute the perceptual hashes of the image plus various transformations of that image, and then commit it to a public data store. Now, once an image has been produced, we now have the, as I mentioned, image analysis service. The way this works is we work with an organization like Twitter. And when Twitter receives an image, the Morpheus system is running in the background. And we ask the question, was this image created by Midjourney or created by some other content producing organization? We then use perceptual hashing to find approximate matches, again, just approximate matches in our data store by perceptual hash. And finally, we run our process called proof of transformation, which is really just Bayes optimization over the original image and the target image to try and see whether or not we can go from the target perceptual hash to the original perceptual hash or vice versa. This allows us to specifically find the exact transformation that might have happened from the original image to the target image, and thus verify whether an image was created by Midjourney or not. As you can see here in the example, we can accurately determine that the target image here was cropped and resized.
Sweet. Nice. So this is general protocol that we expect to work for general systems of AI data provenance for images. And there's a bunch of nuances here, for instance, why we need two hashes, how this scales to different adversarial attacks. Do we need a blockchain to be that public data store? Can we just use a normal database? And what are the different ways it fails? And so we're excited to engage in more discussion with people. You can go to our website at morpheus.pix and chat with us, or view the demo, dragging your own images, check out your own perceptual hash. And then we're excited to continue to build on top of this with organizations that care about AI data provenance.